Dear students, in this video, we are going to see what is a language model. Now here, you should keep 2 points in mind. Whether language used in your query is going to affect the retrieval or language in the document is going to affect the retrieval. Means the way the terms are used, how it is going to affect the retrieval. Means how we are going to relate the probability of those terms with our retrieval that we are going to see in this model. Now we know that in our collection we have many documents. Okay, and based on the need of the information, your user will pose a query. Okay, and you are finding the relevance of the particular document to that query, and you want the probability of it, which you are representing by probability of R given a Q and D. Means I know Q is with me, I know D is with me, but I don't know how much D is relevant to the Q. That relevance only I want to find out, and for that purpose, I'm going to use the Bayes theorem and odds. Okay, so this is what is known as a probabilistic IR, and that we have seen in last video. Okay, now here, we should keep in mind that we can't directly calculate the probability unless and until we know how we are representing that document using a particular model. Means whether we are using a vector space model, or whether we are using the simple term weighting, or whether we are using a language model. Now let us consider a language model. Okay. Now here, what language model is doing is it will use a finite state machine or the regular grammar for representing your document. Means, listen, what are the different possibilities of using the term I wish in your document? I can start with I and I can end with wish. Even I can again come back to I can go to the wish. Means this process will be repeated. And in some cases, it may happen that user wants to find out which I wish. Then whether it is existed in your document or not, that you can find out easily using the finite state machine. So this is what the main language model. Now, what the language model is doing is it is trying to find out the probability of each term in your document. Then I'm multiplying all this probability. And finally, I will get the probability of S in model M. Okay, means this is the answer of my multiplication. Now, there may be two documents. Means in one document, the particular term will have a particular frequency. In another document, it will have the different value for the frequency. So like this, you will represent, okay, a particular term's frequency in the document that you will represent. Then you will multiply it. So you can get P of S oblique M, okay, as given M. Then based on that value, you will try to find out the relation between these two. Okay, greater the probability, less the relevance. Okay, now how we are using the language model. Now, here, each document is considered as a unigram. Unigram means what? Means we are trying to find out the probability of a single term. Okay, we are not going to find out the probability of two terms joined together. Only one term we are considering as a token. Then rank the document D based upon D given Q. How we are going to do it? Apply the Bayes theorem. Okay, B, P of D given Q will depend on P of Q given D into P of D divided by the P of Q. P of Q is what? Probability of query. That will be same for all document. So don't consider it. Then P of D is what? It is prior probability. And generally, for a particular document, it will same. Okay, it will not going to change. Now here the most important thing is you have to find out the probability of Q given D. Means how much that document is relevant to my query. So this is what mainly your language model. Now, in language model, we are using smoothing. Okay, so that a noise is avoided. Because of smoothing, whatever is a noise, what are the unnecessary terms that I want to remove. Then for that purpose, how I am going to find it out? Now, these are my words in the query, and these are the probabilities of in my two documents for those terms of the query. Now here you can see that for algorithm term, both the probabilities are same. But for data term, in D1 it is less than D2. Mining term, it is less in D1 than D2. But don't forget the words the and for, which is having more probability in D1 than D2. But is there any use of this the and for? No. These are just like um, conjunctive words. Okay, means the words which are not useful in my searching. The and for no one be going to search. Algorithm, data, mining, these are the terms people are going to search. So though probability of a D1 is more than D2 because of these two terms, I will try to remove these two terms, and that is what called as a smoothing. Okay. So what are the advantages and disadvantages of this language model is, it is very simple and explanatory. Means if you know the probability of each term, just go on multiplying and compare those probabilities and you will get the relevance. So it is whole and soul based on a mathematics. Okay. And it is using the statistics, not the heuristics. Now, the next thing is language models are accurate representation of the data, because generally user will pose a query in using natural language, and the language model is best representing your natural language. Okay, it means how the terms are distributed, and how the weightage should be given to a particular document based on that term is decided by this language model only. Now, when I'm comparing it with the vector space, then what are the similarities and differences? Yes, both are using the term weighting based on its frequency, and both are considering that the terms are independent of each other and terms are unigrams. I can use even IDF, that is the inverse document frequency. And here I'm not considering the document length. So in both models, the length normalization is required. You have seen in non-binary independence model that you are considering the document length also. Okay, that's why I have used the constant there, K1, K2, and B. Okay, but what are the differences? Yeah, your language model is based on the probability, while the vector space model is based on the similarity. Okay, and based on that similarity, you are considering the angle between the two documents. That is the cosine angle. But here, my stress is on the probability. Okay, and here, what is the difference is I'm finding the document collection frequency. Okay, means how I'm going to use the document length, the term frequency, and document collection frequency. The techniques are different in these two models. Okay, so this was all about the language model. And with this video, I'm ending unit 1. And in next video, we will continue with unit 2. Thank you.